In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum. I am Naima Khan. Today we will discuss three topics: Graviton, Hyperon, and Hadron. First of all, we will discuss about Graviton. History. The term graviton was originally coined in 1934 by Swiss physicists Dmitry Blomstedt and F.M. Galperin. A mediation of the gravitational interaction by particles was anticipated by Pierre-Simon Laplace. Definition: it is a hypothetical particle with zero charge and rest mass that is held to be the quantum theory of the gravitational field. Existence: if it exists, the graviton is expected to be massless because the gravitational force has a very long range and appears to propagate at the speed of light. Gravitons in speculative theories. String theory predicts the existence of gravitons and their well-defined interactions. A graviton in perturbative string theory is a closed string in a very particular low-energy vibrational state. The scattering of gravitons in string theory can also be computed from the correlation functions in conformal field theory. While gravitons are presumed to be massless, they would still carry energy as does any other quantum particle. Photon energy and gluon energy are also carried by massless particles. It is unclear which variables might determine graviton energy, the amount of energy carried by a single graviton. Wavelength. The graviton's Compton wavelength is at least 1.6 multiplied 10 to the power 16 meter, or about 1.6 light years, corresponding to graviton mass of no more than 7.7 multiplied 10 to the power minus 23 electron volt per c square. This relation between wavelength and mass energy is calculated with the Planck's-Einstein relation, the same formula that relates electromagnetic wavelength to photon energy. In quantum theory. In theories of quantum gravity, the graviton is the hypothetical quantum of gravity, an elementary particle that mediates the force of gravitational interaction. There is no complete quantum field theory of gravitons due to an outstanding mathematical problem with renormalization in general relativity. Now we will discuss about Hyperon. The term Hyperon was coined by French physicist Louis Dimitri Blomstedt in 1953 and announced for the first time at Cosmic Ray Conference at Bangry's Debuggery in July of that year, agreed upon by Lapin, Swingwick, Rossi, Powell, Freiter, and Peters. In particle physics. In particle physics, a hyperon is any baryon containing one or more strange quarks but no charm bottom and top quarks. This form of matter may exist in a stable form within the core of some neutron stars. Properties. Being baryons, all hyperons are fermions, that is, they have half-integer spin and obey Fermi-Dirac statistics. Hyperons all interact via the strong nuclear force, making them types of hadrons. They are composed of three light quarks, at least one of which is a strange quark, which makes them strange baryons. Ground state hyperons decay weakly with non-conserved parity. Excited hyperon resonances typically decay by strong decays to the ground state hyperons. Production. Hyperons are produced by strong force in the time it takes for a particle traveling at nearly the speed of light to cross the diameter of a subatomic particle, but they decay by the weak force which is involved in a radioactive decay takes millions of times longer. Because of this behavior, hyperons along with the K mesons with which they are often produced were named strange particles. Now we will discuss about Hadron. In the 1960s, British physicist Peter Higgs postulated a particle that had interacted with the other particles at the beginning of time to provide them with their mass properties. According to quark model, the properties of hadrons are primarily determined by their so-called valence quarks. For example, a proton is composed of two quarks, each with electric charge plus 2 by 3 for a total of plus 4 by 3 together, and one down quark with electric charge minus plus 1 by 3. Adding these together yields of the proton charge of positive 1 yields the proton charge of positive 1. Although quarks also carry color charge, hadrons must have zero total color charge because of a phenomenon called color confinement. This that is, hadrons must be colorless or white. The simplest way for this to occur are with a quark of one color and an antiquark of the corresponding anticolor, or three quarks of different colors. Hadrons with the first arrangement are a type of meson, and those with the second arrangement are a type of baryon. Excited states. Hadrons have excited states known as resonances. Each ground state hadron may have several excited states. Several hundreds of resonances have been observed in experiments. Resonances decay extremely quickly, within about 10 to the power minus 24 seconds, via the strong nuclear force. In particle physics. In particle physics is a composite subatomic particles made of two or more quarks held together by the strong interaction. They are analogous to molecules that are held together by the electric charge. Most of the mass of ordinary matter comes from two hadrons, the proton and the neutron, while most of the mass of the protons and neutrons is in turn due to the binding energy of their constituent quarks due to the strong force. That's all. Thank you for your attention.